My name is Hebert. I'm the director of the Robotics Institute and also a professor here. I started my work doing object recognition. In other words, being able to recognize automatically the location and orientation of objects. This was in fact at the time, now we're talking 1982, at the time for industrial robots, a task that is called bin picking. The idea of being able to grasp objects out of a bin, which is still, by the way, an important problem in manufacturing. And then a couple of years after that, I moved here and started working with a whole team here, of course, on autonomous driving. At the time, we were not calling that self-driving, it was autonomous ground robots. It was, in fact, the first program, I think, on, at least of that scale, on self-driving and autonomous robots. It was called the Autonomous Land Vehicle. It was a DARPA program. And the first, attempts or demonstration at what we call now self-driving. Yeah. Well, let's see, the robotics aspect, of course, were always influenced by that, and in particular the idea of devices, machines being able to reason and make decisions, about the environment and their actions. So that certainly is a component that's always been, fascinating, right? I cannot remember a specific one that influenced me. It's more, this body of popular culture on robots and intelligent systems, basically. Right, well, I've worked on, and I'm still working on many aspects of computer vision, and basically machine perception, both for different kinds of robots, ground robots, flying robots, as well as computer vision in general. Two of the things that I'm particularly interested now, one has to do with being able to learn how to see in computer vision with minimal supervision. We've all heard of the progress due to deep learning, deep learning techniques that are revolutionizing the field. The problem with many of those learning techniques, all of them actually, is that they require a very large amount of data. Somebody has to tell the system, this is what I want you to learn, and it has to give many, many examples. In the case of computer vision, of images or videos that are annotated. And it's fine if you have, all the time in the world and all the manpower in the world, maybe if you Google or Facebook or something. But in practice, that's not something that can scale. And in particular for robotics, one has to be able to adapt very quickly. One has to be able to retrain, to relearn new concepts very, very quickly. And for that, one has to be able to do it with minimal supervision, with little data. The second class of problem that is of interest to me these days is this issue of, there's different name for it, of introspection or performance prediction, etc. It's the idea of systems, in particular vision system, but not just vision system, being able to understand their own performance and be able to predict their own performance and be able to act on that. Okay, this is a capability that we humans have to a very large degree. We know our own capability, and we know, not only we know our own capabilities in absolute terms, right? We know how fast we can run or things like that, but we also know them in relative terms. In other words, something happens in the environment, we know how we should adjust our behavior. So, for example, take a very stupid example. If you're driving and you're suddenly surrounded by fog, right? You don't have to reason about it. You know your visual system is impaired, and you know intuitively in what ways it's impaired. Basically, visibility, distance that you can see, and you're going to immediately adjust your behavior accordingly, right? It's very important to be able to endow autonomous system with that kind of capability. One reason is that it will never be the case that vision systems, for example, will be 100% correct. That will never happen. Nothing is ever 100%, correct or performant, right? Instead, we need to have systems that recognize, hey, I'm now in a situation when maybe, for example, my vision system is not performing very well. And maybe it's not performing very well in that particular way. And so I now need to use a different type of behavior. Or maybe I need to do this action to try to improve the situation and see better, right? Like I might turn on my anti-fog light or something, okay? So that's something that I think is critical for robots to be deployed in the real world. Being able to carry out tasks over very long periods of time and reliably. Okay, this is very different from the offline application of AI, Alexa-like, etc., which have completely different set of very tough challenges, but they don't have that one. They could be wrong once in a while. They could, be in a situation that they cannot handle and just be wrong. You can't do that if you have self-driving car or any kind of system that needs to make decisions continuously all the time and in a way that can lead to critical decision or catastrophic decision in some cases when humans are involved. Right? So that's the second broad area basically that I'm interested in. And the two are linked, of course. The two have to do with how to take some of those AI techniques, in this case computer vision, and adapt them so that they can work on actual robotic system that operate in the real world continuously and interact in humans in particular in ways that can be critical. Let me tell you why it's difficult to answer that question. Is because when it comes to the type of complex systems that we're talking about, the robotics one, the one that interact with people, self-driving and all that, there's no such system yet, really, right? That are truly by that I mean that are truly operational with the general public, on a day-to-day basis, right? So in that sense, it's a little bit difficult to find example of such system when the communication was right. Another thing that people ask quite often, and maybe that's one of your questions later, is when will a truly intelligent system be deployed with people? Or when will we have true home robots, for example? And my answer to that is that we already do, but we have to be careful as to what is the definition of complex systems. When you ask So one example is the vacuum cleaners, right? The new generation of vacuum cleaners from various companies. I'm not in any company in particular. The level of intelligence that is in those machines is amazing. Okay, and I think it's in a way to me it has not been quite communicated right, but in a different way than what we think sometimes. I think we meaning the field, should brag more about that. The level of intelligence that they have in terms of mapping, sensing, people detection, people understanding. And I'm talking about the new generation that's either under development or recently developed. And that's an example of a system that has a very high degree of AI in it, that actually interact in the environment. It's not just a question and answer system. It actually does stuff, right? It moves, does stuff, it interacts with people. The distinction here is that because of the nature of the task, it's it's not going to hurt anybody. As a result, there is a level of performance that's acceptable. Okay, and I find that interesting. In other words, instead of thinking, from, the general research and then all the way to self-driving cars deployed everywhere with everybody around moving at high speed and stuff, there's all kind of intermediate stages, right? That by the nature of the task, slowly evolve from the completely safe task, because they just question answering, they can be wrong sometimes and so forth, evolve from that to things that are more and more challenging in terms of interaction with people and safety issues and trust issues and all that. But you see, they slowly evolve that way. But yet, even if you look at those early things, like you could think of a vacuum cleaner as being a very intelligent thing, the fact is they have already a very high degree of intelligence. If you look at the nature of the AI techniques that are used in them. We need to be very careful that we state clearly what each component is capable of doing and not capable of doing. Okay? As well as there is a concern about the, how can I say, sometimes the bias that goes into those things, or the designer bias. Not that we do those kind of explanations very well, but there has to be, we have to be careful to explain what comes from choices, design choices, right? What comes from the data itself, right? There's a lot of discussion about data bias and all that. In fact, there's a very difficult explanation. I was talking to colleagues actually last week about this. We had a long discussion about this. There is something that I don't know exactly how to explain, so maybe I shouldn't. But there is a distinction between the data bias in the sense that I, or the group designing the data, did not introduce their own bias in designing the data, and therefore the system is biased in some way. The more complicated, but that to my mind is not really an AI problem. This is something that exists in all areas of life where people use data to draw conclusions. Okay, so it's the same problem basically, and there are tools to deal with this. The fact that it's AI, to me, does not necessarily make it worse. Well, it might make it worse because it might make more decisions based on that, or more decisions automatically, but fundamentally the problem is the same, right? Whoever designed the data did not follow the proper ethical rule in sampling the data. But there is a problem that is much harder, which is that we don't understand necessarily the effect of the data distribution on the behavior of the system when it comes to the newest AI system, things like deep learning, black box kind of techniques, right? So it might be that a data distribution that from normal statistical tool is fine. It's not biased. It passes all the tests that conventional, so to speak, ethical and statistical people have designed. Yet it does exactly the wrong thing, because for whatever reason, this black box architecture that uses it is sensitive to some strange configuration of data. That is extremely hard to characterize, and that's something that can be very problematic, and it goes to this more general thing. I was talking about this performance characterization, this more general point of trying to understand exactly what those learning techniques, those AI techniques do, those black box techniques, right? There's some terminology floating around like explainable AI and things like that. So it's not just explaining how the system gets to a decision. It's also explaining the influence of variation in the sampling of the data in the behavior of the system, which again can be very different from what we think of in terms of classical statistics. And to your earlier question, so there's two problems with that part. And sorry I was long-winded in explaining it. I have to find a way to make that more concise. But there's two difficulties. One is a communication difficulty, how to explain that, and the distinction between making sure that there's, for example, there's the right percentage of people of different types in a sampling population, for example, which is classical statistical thing. So there's the communicating that, and then there's the fundamental research problem of how do you even get a handle on how to characterize those effects, right? There's two ways that AI system can impact how people work, right? One way is to take existing processes or existing tasks, existing ways of doing things, and completely transforming them by taking, perhaps sometimes actually surprisingly, one very small part of that process. And just by changing that very small part of that process, it actually transforms everything, right? And it enables now people to do it in a completely different way, perhaps much more efficient, etc. So we work, for example, with a number of companies on manufacturing processes in that way, where we look at things that have been in place, frankly, for decades. Okay, same way of doing things. And then you inject a little bit, just a little bit of new, AI or data-driven technique, and you can truly affect in a big way how things are done, either for efficiency but also for safety, okay, and things like this. That's one category of tasks. The second one is enabling completely new things that were never possible before. Okay. So, for example, we have, work in surgery for, being able to do surgery without incision and things like this. That can be coupled even with other things that look at vital data continuously and can, anticipate problems like your patient going into shock and that kind of thing. That can be also combined with other research on sensing that allows continuous monitoring of blood and things like this in a non-contact way. All those things together enables completely new ways of doing medicine and surgery. Right? In manufacturing, we're looking at modular robotics type of thing, completely reconfigurable system and rapidly trained system that again enable eventually will enable, for example, individuals, small enterprises, to be able to put together a state-of-the-art robotics facility, something that is absolutely impossible now, right? So you see, it's not just improving things a little bit; it's making things possible. In education, in computer vision, a lot of the progress has to do with people understanding. So being able to understand people's facial expression, body posture, motion, intention, right, internal state. If you have all those things together, you can now redefine what it means to have virtual classes or intelligent tutor, because now it's not just a matter of watching of the student watching a video online or even having some textual interaction and all that. You can imagine a system actually truly understanding the reaction of the student, and just like a real teacher would do, right, and truly adapting on the fly, right. So that's another place where it's creating completely new ways of thinking about education and things like this. So I think there's a lot of places where it's going to create completely new opportunity and completely new skill that, frankly, in many cases we don't yet imagine, really. Yeah, I think so this is the optimistic view, right? If we parallel a little bit with the changes that came about, well, basically the laptop, and the digital revolution, as it's called sometimes, right? What it did is to first give more independence to people. Okay, they can do things independently by themselves. And empowerment, So to again go to the digital revolution analogy, I'm old enough to remember when there were a lot of the work that was being done had to do with pushing paper one or another. Okay. Now you have people being able to do with an Excel spreadsheet things that you would have a highly paid engineer with an IBM mainframe 40 years ago. And if you think of it in this way, it's incredible empowerment, right? And so the same thing will happen with AI now. So, for example, you need to think of being able to do some kind of document research, either because you're an employee somewhere or because you want to create your own business and you need to search through, I don't know, some patent things or some documents, some literature and all this. Now you can't do it. Or you can do it, but it's going to be very expensive, you need to have. Then you will be able to do it, because you will have AI agent that will be able to answer any question you have about any massive amount of data you want. Okay? So that's the same analogy, basically, with the spreadsheet kind of thing, right? So that's the idea of independence and empowerment. Okay. Now I know it's a little bit generic. I'm not giving you a specific scenario here, and part of the reason, frankly, is that, again, I don't think we have completely worked through all the possibilities. Just like in the digital case, when those tools were first introduced, some of the things that are obvious now certainly were not thought of at the time, right? Well, but that's the interesting thing, you see, is this notion of, I don't know what the right word is, but of lowering the barrier to entry. Mm-hmm. You see, when you said it's professionals only, that's not true in the case of the digital revolution. In other words, people who were office clerks, office workers, now are people who can have access directly, mm-hmm. and are able to use all those tools directly. Right? So in other words, because it lowers the barrier to entry, you have now a whole segment. I think of it actually the other way. You have a whole segment of the population who is not considered, professional or being able to do the kind of things you mentioned, now able to do that. Right? Mm-hmm. So that's. You can think of it as lowering the barrier to entry, or as having technology being less and less elitist. Yes. Because now more and more people can use it. Mm-hmm. Okay? Now, I understand where the question comes from, right? Because when we talk about AI, we talk about things that can make decisions, things like this, and perhaps this flavor that it is only for people who have some kind of training in those fields. But you could turn that around completely. Mm-hmm. Again, following the digital example, right? That it's going to basically democratize potentially technology and make tools accessible and tasks accessible to segments of the population for whom it was not accessible before. And by the way, that includes also, in terms of human dignity, there's another thing that I'm hopeful. Now, there's some political aspects to it, so maybe it won't work, but I'm hopeful that it will make a big difference. There is the issue of isolation of certain population, right? The discrepancy between, the large urban centers and the rest, basically, that's isolated. Now, AI can provide can make an enormous difference here by providing technologies that allow, both in terms of logistics, in terms of transportation, right, in terms even of medicine. Because now if you can lower the barrier to entry for some advanced medical intervention, surgery or otherwise, remote diagnostic, things like that. Education, the example I gave about education, right? Now you could imagine having, top of the line, high schools and things like this available everywhere, because now you can have those virtual teachers that are true virtual teachers, not just watching a class on the video, right? So in that sense, again, the optimistic view is that it will provide tools that will reduce the discrepancy between those two sides of the population, and essentially, again, lower the barrier to entry, because now you have this other side of the population that has access. I guess some aspect of automation in the context of field robotics, mm-hmm. for example, would fit the bill, where you have basically completely automated system.
Yeah.
executing some task. Right, so in mining and other applications. So that would be one. It has certainly changed the workflow and how the people involved interact with the system. But in all of those systems, and this is sometimes a little bit of a misconception, they remain fully in control of the system. That is the case in any system I can think of at the moment, right? So the organization, of course, changes, and the roles are going to change. But in terms of control, there still remains with that human team, right?
Mm-hmm. Do you imagine that we'd relinquish that control?
No, actually, I don't.
Not in any system.
No, not even a vacuum. There is an issue, another issue, the issue of trust, of course. It can happen that the system makes a decision or has behavior that is not acceptable to the controlling team. But that can always be corrected, or that can always be controlled. In other words, to me, this issue of relinquishing control is not, it's not, to me, it's not quite the difficult question, because we always have control. We can always, stop, and we design the system and whatever. The more difficult question is the one I had at the beginning, which is to have systems that can properly anticipate when they're going to be in situations that they cannot handle, when they're going to be in situations where they know their behavior is not going to be understood, or not going to be the right type of behavior that would be expected by the human team. So having the system recognize that is the hard question, I think. Mm-hmm. Right?
So you're arguably one of the most seasoned roboticists and developers of AI systems. So I can imagine the ways in which your position affords you that notion of control. But I'm wondering if you can imagine the ways in which other individuals who might be configured around a system that is making decisions may have to be educated.
Yes, so that is true.
About those dynamics.
Yeah, that is correct, and that has to do also with this issue of communication. By that I don't mean wireless communication or something. I mean communication in the sense of the system acting in ways that are legible and understandable by the team. Yes, and on the other side, by the team being properly trained and explain what is expected of the system, what the system can do, what it cannot do, including what kind of mistakes the system may make.
Yes.
After all, as humans, when we work together, we do have a mental model of each other, and we know, kind of roughly speaking, our limitation and the kind of mistakes that we can make. Okay, and the same should occur there. I think one mistake sometimes is to think of because it's an AI system or something, it's going to have be infallible or something. It's going to work perfect. But that's certainly not the case. Okay. So that's where this communication is important. Coming back to my earlier comment about performance evaluation, is this idea of being able to formally document and explain this limitation of the system, so that like you were saying, there's the proper communication basically between the person and the system. And by the way, when I said, I don't mean to minimize, by the way, the problem. Those things are still very, very challenging things to do. Okay, it's not like those are solved problems at all. But coming back to the issue of power and things, I think those are the key issue, more than worrying about somehow not being in control at all. Certainly some of the manufacturing systems that are around, especially some of the ones that are emerging with more collaborative manufacturing can be used as examples like this. On the non-robotic side, any of the emerging question-answer systems, not just the question-answer, Siri-like and all that, but also the ones that allow you to analyze large amounts of data to find information quickly, which you could not do before, or you could do at enormous human cost. Not human cost, but labor, time, yeah. Predictive maintenance, for example, right? So those are systems that can look at such massive amount of data and have such elaborate techniques to predict, failures or need to maintenance from that very large amount of data. That's something that no human could or team could possibly do, for example. Even the autonomous systems. Okay, I know that's the debate. That's a debate about self-driving, and we can debate that. But many of those systems, there is still there's still human control. The ability to be able to carry out tasks in complex environment. And one thing that potentially machines can do better than human is to make decisions quickly in complex situations. We were talking about the World Cup not long ago. And if you think about it, one of the capabilities that those players have is the ability to quickly understand a lot of data.
Yes.
In terms of situational awareness and things like this. Now, potentially, autonomous systems, AI systems, can have that capability at a much, higher degree than we can have, right? So that goes to the aspects of safety and performance and all that they can achieve potentially higher degree of those things because of those higher capabilities. In traditional engineering, right, when you build a complex system, an airplane or nuclear power plant, you're not afraid of going in an airplane. Why? Because implicitly, behind this airplane, there's 200 years of engineering practice, even before airplanes existed, right, with best practices, formal tools, formal method that have evolved over, 200 years, maybe approximately, that engineers know how to, given a complex system, to say if the system operates under those conditions, the performance of the system will be within that envelope. Okay, that kind of thing. And there's this entire body of engineering science, basically, on how to do that. The problem with AI system or robotic system is how do you do that now with systems that use machine learning components, such that the performance of the system depends on the data, not just on the correctness of the code of the machine. And worse than that, how do you do that with systems that evolve over time? So now it doesn't just depend on the data you use initially, but it evolves. How do you do that with systems that have complex interaction with people? Complex meaning that the system itself guesses what the intent of the person is, right? Which is what is going on typically in the recent AI and robotic system, right? How do you do that with systems that have very large amounts of sensor input from which they extract that information? Large amount of sensor inputs, the failures of which can no longer be characterized explicitly, in a purely, traditional engineering way. So how do you do all those things? So we don't know. Right? I mean, we don't know. There's a lot of work on this. Of course, there's some tools for this, but we're far from having the level of practice that exists for, let's call them standard engineered system. Right? So that's the biggest challenge. Okay. The biggest challenge to me is not improving this particular vision system so it works, at 95% instead of 90%. I mean, that's a big challenge, but that's something that we kind of know how to do research on and know how to make progress on. The kind of thing that I described need new tools, new ways of thinking, maybe, new practices. that question comes up, of course, all the time, and I wonder if it's, and this may be the wrong thing to say in this kind of AI forum, but I wonder if it is so different from a classical, let's call it classical, complex engineered system.
In what ways?
Well, in the following way, that just like in a complex engineered system, a plane, for example, that can kill a lot of people.
Yes.
Okay, it is the responsibility of the designer to have the kind of formal performance characterization that will guarantee that at a 10 to the minus 9 or 1 minus 10 to the minus 9 probability, it will not crash when you get in it. Okay, that's what they do, right? So that responsibility is the same in that sense.
So
right?
in that regard, the more traditional engineering systems offer us a paradigm that we might be able to construct
to me, the question is not really whose responsibility it is. It is the responsibility of whoever designed the system in a way, right? Just like for an engineered system, right? The real question is how to, the same thing I said earlier, how to develop the tools such that that responsibility can be effective, right? So that when I put a robot that's going to operate next to you or something, I can tell you those are tell you the general public those are the procedures and the processes that we followed, and this is the expected performance, and those are the limitations of the expected performance. I mean, when you get on an airplane, there are limitations, right? I mean, the constructor, the manufacturer of the airplane can tell you, there are birds hitting the airplane, and the engine will cease, right?
And there are maintenance expectations.
There's maintenance procedure and things like that, right?
And limitations in terms of stressors and use over time.
Yeah, right. And so that's well understood in traditional engineering. We need to develop all of that in the AI and robotics field, right? And that's going to take a while. That's going to be faster in traditional engineering because things happen faster, and we have all that experience from before. But that's what really needs to happen. That to me is the big question. How to do that, how to push that, and also how to make sure that some systems are not deployed before they are properly tested like this. Okay, but that is no different. That's what I meant. It's at a high level, it's no different from any other engineered system being deployed too quickly before it's properly characterized, right? In terms of the responsibility question, right?
Yeah. So would kind of clinical trials, drug approval, be another paradigm that would? That's
another one. Yeah. And in fact, there has been a lot of comparison between the self-driving testing and some of the protocol, particularly in terms of the risk involved, and the protocols used for drug testing, for example. I think, yeah.
So that's something that you would advocate for, you think?
Yeah, we should learn from those things. Yeah. But basically, what I'm saying is we should look at those questions from this kind. I mean, maybe that's too strong of a statement, but it's more important to me to look at those questions from this kind of technical viewpoint, rather than speculating as to whose responsibility it is, and especially starting to talk about responsibility of the AI system itself and things like that. Okay.
Yeah. So it allows us to work within the paradigms that have worked for quite some time, rather than going into the hysteria of science.
Yeah, exactly, and keeping a very down to earth, maybe boring approach that there are systems that can make decision at an unprecedented level, but they are still, in a way, they are still engineered systems. They're just of a different nature, right?